Hi everyone, I am Dr. Subbarao from RVIT Institute of Technology. In this video, I am going to explain N-type semiconductors. So, what are N-type semiconductors? N-type semiconductors are created by adding small amount of pentavalent impurities like phosphorus, arsenic, and antimony to a pure semiconductor like a silicon or germanium. So, the N-type semiconductors were fabricated by using the pentavalent impurities. Pentavalent means the valency of the atoms are having the 5. That means 5 electrons present in the valency of the atom. So here phosphorus, arsenic and antimony, they are having the 5 electrons in their valency. That means the number of valency electrons present in phosphorus and arsenic and antimony is equals to 5. So these are the pentavalent impurities. So the pentavalent impurities are added to the pure semiconducting material. Pure semiconductors are the silicon and the germanium. So by adding the pentavalent impurities to the pure semiconducting material, we get the N-type semiconductors. Now, for example, phosphorus doped silicon. Here phosphorus is the pentavalent impurities doped in a pure silicon semiconductor, and arsenic doped in a germanium, antimony doped in a silicon, and phosphorus doped in a germanium. These are the examples of N-type semiconductors. So here consider this phosphorus doped in silicon semiconductor. Here the silicon having the valency 4. That means it forms covalent bonds with 4 other silicon atoms. And coming to the phosphorus, the atomic number of phosphorus is equals to 15. And the electronic configuration of phosphorus atom is neon 3s2 3p3. This is the valency electronic configuration of phosphorus. Here neon having the 10 electrons and the remaining 5 electrons exist in 3s2 and 3p3 orbital. The 3s2 orbital having the 2 electrons and this 3p3 orbital having the 3 degenerate p orbitals. So that means 3px, 3py and 3pz. Each orbital having the single electron in a clockwise direction. So these are overall 3 electrons present in a 3p3 orbital. Now, if this 2s orbital absorbs some part of energy, then what happens? The electron enter into the other orbital. That means here this 3p having the half-filled electrons. That means these orbitals having the more stability. That's why whenever this phosphorus atom absorbs energy, the 3s electron enter into the other orbital. That means d orbital. So the excited electronic configuration of phosphorus atom is 3s1, 3p3 and 3d1. Here the electron from 3s orbital enter into the 3d orbital, not pair with the 3p orbital. So here this is the electronic configuration. 3s orbital having the 1 electron and 3p have the 3 electrons and d orbitals. There are 5 d orbitals: dxy, dyz, dzx, dx square minus y square and dz square. These are the 5 degenerate orbitals. Here the first electron enter into the 3s orbital in clockwise direction and second electron enter into the 3pz orbital in clockwise direction and the third electron enter into the 3py orbital in clockwise direction and the fourth electron enter into the 3px orbital in clockwise direction and the remaining fifth electron enter into the 3d orbital in clockwise direction. Here the total number of valency electrons is equals to 5. So this 3s, 3p and 3d, these are having the unpaired electrons. Overall 5 electrons. So this is the phosphorus atom. This phosphorus atom having the 5 valency electrons. That means it can form 5 covalent bonds. Here these are the 4 electrons and another electron. Overall 5 electrons. This silicon having the capacity to bond with 4 electrons. So that means each silicon is surrounded by 4. That means phosphorus also contribute to 1 electron. Then phosphorus is surrounded by 4 silicon atoms. So here this phosphorus is surrounded by 4 other silicon atoms and contribute to each atom to 1 electron. That means 4 silicon contribute 4 electrons and phosphorus contribute 4 electrons. Here they forms the covalent bonds, and 1 electron is a free electron is remaining in this valence. This conduct the electricity. So the free electron present in the valency of phosphorus doped silicon semiconductor conduct the electricity. So the majority charge carriers in N-type semiconductors are free electrons. So in P-type semiconductors, the majority charge carriers are holes due to the presence of vacant orbital. Here there is an excess electron present in valency which conduct the electricity. That's why the N-type semiconductors having the majority charge carriers are free electrons and the minority charge carriers are holes. How these forms the N-type semiconductors? Here the phosphorus have the 5 valency electrons and silicon having the 4 valency electron, and each phosphorus shared the 4 electrons with 4 other silicon atoms. So the each phosphorus atom is surrounded by 4 other silicon atoms. Here this is the phosphorus atom and this is the silicon atom. This silicon atom forms a covalent bond with the phosphorus, and another silicon forms the covalent bond with the phosphorus, and the third silicon atom also forms the covalent bond, and fourth silicon atom also forms the covalent bond. This is the way the phosphorus contribute the 4 electrons with the 4 other silicon atoms. So the 4 other silicon atoms contribute to 1 electron each and paired with the phosphorus unpaired electrons. Here 1 electron left in a phosphorus atom. This is the free electrons. We called it as a conductive electron. So conduction electron means. And these silicons are further forms the covalent bonds with other silicon atoms. So this is the formation of the N-type semiconducting material. And this material have the free electron. This is the conduction electron. Due to presence of this conduction electrons, the N-type semiconductors conduct electricity. Now, how they conduct electricity? Here, this is the N-type semiconducting material. One end of the semiconducting material is connected to the positive terminal of the battery, and the second end is connected to the negative terminal of the battery. Here, for P-type, the positive terminal creates the holes, but the electrons are present at the negative end. That means here this negative end have the electrons. These electrons passes through the semiconducting material, and here these electrons moves in forward direction, and the formed holes are passes in backward direction. That means one is in forward bias. That means electrons in forward bias and the holes in backward direction. That means they have in the opposite direction. The mobility of holes in opposite direction. This is the reverse bias. Now coming to the valency band. In P-type semiconductors, we observed that the valency band having the holes, free holes, conduction holes. But in case of N-type semiconductors, the valency band have the free electrons and the conduction band have the, here holes are present at the conduction band. And the electrons enter in from valency band to the conduction band. But in case of P-type, from conduction band to valency band, the electrons are moving. So here the electrons are moving from valency band to conduction band. And coming to the applications of N-type semiconductors. The first one is the transistors. Here N-type semiconductors are also used for the construction of transistors and metal oxide semiconductor fields. We call it MOSFETs. MOSFETs are the boards, electronic boards having the different semiconducting materials. For example, ICs, capacitors, and diodes, transistors. These are exist in MOSFETs. Next one, integrated circuits. These N-type semiconductors are used for the construction of integrated circuits. And next one, diodes. So these are also key components for the construction of diodes. These N-type semiconductors combined with the P-type semiconductors and forms NP junctions and PN junctions. They created the paired electrons, and here P type of conducting materials having the holes and N type semiconducting materials having the electrons. Due to the formation of the electrons and holes, they conduct the electricity, and they are also used as a converter for the AC current is converted into the DC current. For that conversion, this diodes will be used. Next one is the solar cells. So these N-type semiconductors are also used for the solar cells. That means for construction of voltaic cells, they are used N-type semiconductors for conduction property. And the next one is the light emitting diodes, LEDs. LEDs are also, these are the materials which convert light energy, electrical energy into light energy. For that purpose also we are using N-type semiconductors. And next some other applications. These are used for the fabrication of sensors, radio frequency devices, and other electronic components. These are having the essential applications for the electron flow, and these are used in wireless communication equipments, and these are also used for the construction of logic ICs. And these are used for the making medical electronics, such as amplifiers in ECGs and imaging devices. And also utilize N-type semiconductors for the imaging purpose. Thanks for watching. If you like this video, please like, share, and subscribe. Please click the bell icon symbol for more informative videos. Thank you.